As a part of our engineering mechanics syllabus, so far we have seen coplanar concurrent forces acting on a particle, coplanar non-concurrent forces acting on a rigid body, parallel force systems, and we saw topics on how to extend these to 3 dimensions by considering vector notation for forces as well as vector notation for moments. We have seen that sigma f bar is equal to 0 and sigma m bar is equal to 0 stand as equations of equilibrium in vector notation. We'll try to shift gears and try to come into the third unit of your syllabus, which deals with centroid, center of volume, center of line segments, center of mass, and finally center of gravity. These topics may be of importance to us in contexts where we want to find what is the geometric center of a plane figure, what is the center of volume, what is the center where a plane figure will balance on a pin tip, and where we want to draw line of symmetry, and finally where we can show the gravity force of an object is acting. That is, we want to show a point and say the entire weight of the object is concentrated at this point. This study, as the title of the next unit of your syllabus says, is centroid, center of mass, and center of gravity. Before we study these, let us look at a fun activity and then we'll continue on. Try to make the object that is shown in, and definitely go to YouTube and like or share Nimesh Soni as shown in the coming up video. hope you liked that little fun activity. As I was mentioning, please do go to YouTube, find the page of Nimesh Soni, like it and share it as much as possible. Let us give due credit to himself. As shown in that video, the object that was made can balance itself at the tip of its beak, so to say. Before going further, I would encourage you to pause this video, take a piece of paper, make that shape, and see for yourself that the object is balancing. If it's not balancing, find out what went wrong and rectify it so that it balances. The subsequent topics in this unit focus on how to locate such a center mathematically. For the case of plane figures, you call it centroid or geometric center of the plane figure. For line segments, again you can call it centroid. You have center of volume, you have center of mass, and center of gravity. We would like to be able to find these points by writing mathematical equations. That is, we want to find mathematical framework. We begin by considering plane figures, that is thin lamina. There may be sheets of metal, sheet of plastic or paper or something like that with negligible thickness. We say that they are plane figures. Let us begin by looking at the definition of centroid, one definition of centroid, and look at a few properties of centroid. Okay, centroid of a plane figure is a point, okay, which need not necessarily lie on the figure itself, such that any straight line, the property of the centroid is that any straight line drawn through that point divides the area into two parts, and those two parts have equal areas. The thing that you need to focus on is the word centroid is a point. The point need not necessarily lie on the figure itself. Many times it lies, but it's not necessary that it lies there. And the property that the point has is that any straight line drawn through that point divides the area into two parts, and these two parts have equal areas. Look at this circular lamina. It is hatched here to show that it is a circular sheet rather than a circular wire. For example, this line divides the circle into two halves, top and bottom, and so does every other line. So we say G is the centroid, which is the geometric center of this circle. Similarly, the point G here divides any line drawn through this point G. For example, this diagonal divides it into two halves, half to the left, one half to the right, and these two parts have equal areas. Similarly, if you draw a horizontal line, this horizontal line will divide this rectangle into two halves, top and bottom. So G is the centroid. So the point we take home from this little discussion is, if there is an axis of symmetry, if there is a line of symmetry as shown here, this line is a line of symmetry, this line is a line of symmetry. When you actually cut an object along a line of symmetry, you can take the two halves and stack one on the top of the other. Every point coincides, every point on one part coincides with the other. Okay, that is the take-home point. Look at some more cases. Let us look at the case of this rectangular lamina in which a hole is made. Okay, again you can visually see that this is an axis of symmetry. This horizontal line is an axis of symmetry. This vertical line is an axis of symmetry. Their point of intersection locates the centroid. Note now that the centroid is not lying on the plate because this is a hole. Similarly, in the case of a circular lamina, if you make a circular hole concentric, again this centroid lies at its center, which is not existing on the sheet. It is floating in thin air. So we see that when a plane figure having an axis of symmetry is folded or cut, for example here if you cut it, or along this diagonal if you cut the circular, each part can be stacked on the other so that corresponding points exactly line up. So it is very easy for us to identify the centroid if there are lines of symmetry. But consider the other objects that are coming up over here, either this irregularly shaped object or the rectangular piece with asymmetric holes, or this object which doesn't have an axis of symmetry and there are asymmetric holes. It is not possible to find out centroid by inspection or by considering line of symmetry, because a line of symmetry doesn't exist. In such cases, we need to use mathematics to find the centroid. That mathematical framework is what we are going to see in subsequent lessons. What we are going to do is, step 1, we establish an x-axis, we establish a y-axis. We identify what is the leftmost point here with a coordinate x subscript L. What is the rightmost point? X sub R. We consider a small strip at a distance x having a thickness of delta x whose height is y. And we do a little integral in between the limits xl and xr to find out what is the centroid. We'll try to cover such topics in subsequent classes. I would encourage each and every one to go through this video thoroughly. Then again, as I said, go to YouTube and like Nimesh Sony's video, and then try making out that object which is shown in the fun activity.